Okay, hello everybody. I'm here in Dublin. We are streaming live from Dublin. Barry is with me from the Java user group.
Hi there, everybody from around the world. You're very welcome to Dublin. We have Simon here. He's just onto his second talk, which is being streamed to you around the world. And all our attendees are here. We're just going to say hi to you from Dublin there. Big cheer, guys. Hello. That wasn't an Irish cheer, but big cheer, guys. Yeah, that's better. So there we go.
Awesome. So thank you everybody for joining. I will be moderating this session for the J Champions Conf. So I'm really happy and looking forward to learning a lot from Simon today. Simon Martinelli will be speaking about goodbye microservices, hello self-contained systems. A quick introduction about Simon. He is a Java champion, a Vaadin champion, an Oracle Ace Pro. He has 30 years of experience with Java as an architect consultant. He's also a lecturer at Bern University for Applied Sciences. So a warm welcome to you, Simon, and there you go.
Thank you very much. Yeah, my talk is goodbye microservices, hello self-contained systems. Show an alternative to a architecture style that was very popular in the last 15 years. It's maybe less popular now, but we will see. So I skipped the introduction. Now, in the first part of my talk, I will do kind of way back in the history or in my history. And for me, it started like this. So I started as a COBOL developer in the wild, wild west until 1999. So I was helping solving the non-existing year 2K problem, non-existing because we did a lot, but nothing happened at the end. And after that was solved, I had the chance to move to the Java space. And when I started in year 2000, 2001 with Java, it was all greenfield. I was working for Swiss Railways back then. We built the first online ticketing system, or the second one in Europe. I think the first was Sweden and Switzerland was the second, not with a mobile device, but with tickets on paper that you can print at home. And we built a lot of systems. So they were all monolithic because simply based on the infrastructure that we had, it was simply not possible to run microservices and no one was talking about it. So in 2010 or around year 2010, there was primarily Netflix and other people talking about microservices, introducing how they use that. But people didn't listen carefully enough because they were listening to Netflix. And I never worked for a company like Netflix, right? So the biggest company that I've ever worked for is Swiss Railways. They have around 35,000 employees in Switzerland. It's one of the biggest companies because Switzerland is very small. And we never had such amount of users. So why should we use a technology or an architecture from a company who has a complete different requirement, right? But people were not listening. They were saying, hey, microservices is cool. We can work independently. We can scale up, down, whatever. As I said, my customers don't need to scale up. They can scale to whatever the requirements are, and then it's done. So they will not have peaks. For sure, the online ticket job has peaks. So they really have a lot of users now. Back in the days, not so much, but now they have. But what happened then is this. As you can see, I used a lot of AI because I'm fascinated by Claude AI and ChatGPT and DALL-E and stuff like that. And it's funny. So they created a mess, right? So they created a lot of microservices because the size is really important. I will talk about that later on. Funny thing, I was working for the biggest retailer in Switzerland, and they had issues with their microservices. And then they came to me and asked me if I could help them and stuff because they were accessing an external SAP system, and this was not very stable, so they had issues blocking, stuff like that. And then I introduced microservice pattern. I explained them how they can use circuit breakers and stuff like that. And by the way, I asked them how many microservices that they have. And they told me that they have 20. And then I said, wow, you must be a huge team. And then they said, no, we are just 3 people. And so that's a bit the problem. So if you split, how do you split? I took this picture here from another presentation because very often people are comparing these 2 things. So the thing on the left-hand side, you may know, that's called a big ball of mud. And that on the right-hand side, you may not know, no chance, because this is a monolith. But it's not a monolith built of stone or something, it's a monolith built of metal. This was in the lake close to where I live, built by Jean Nouvel. He's a French artist. And we had the Swiss exhibition in 2002, I think. Yeah, it's already a long time ago. But this is a monolith. And the interesting thing about this monolith is it was beautiful inside because they had huge paintings, 360 degrees painting from the battle of the town that they had, like, I don't know, 400 years ago or 300 years ago. So monolithic applications are not a big ball of mud, right? We will come to that later. Now, funny thing is, that's David Parnas. Does anybody know David Parnas? He was very popular in the 70s, 80s. He was writing a lot about systems architecture, how to build systems. And he wrote in 1972 a paper that was called On the Criteria to be Used in Decomposition Systems into Modules. And what he said is it's only efficient if you do it right. So you have to find the right cut. And he was not talking about microservices back then, right? He was talking about small components in small microkernel systems, whatever, right? So the point is that microservices are not new, or any architecture style is not new. It's just a different word for something that we already did for a long time, because it's about modularity. So we need to split the system into modules. Maybe we don't need. So my Hello World example from before don't need to be split. It's small enough, right? Or big enough, or whatever. And modules, that's also a term from David Parnas. He wrote about that. Is a component is a system that is interchangeable and it has a well-defined interface. And that's the benefit of microservices. So you can exchange it. So I'm working on a lot of modernization projects lately because these systems that we built on greenfield are now old and they have to be replaced somehow. And if we had microservices or a modular approach back then, we may be able to replace them easily because we just can exchange the modules. We can't do that. But again, the problem is not the monolith. The problem is that we did not care about modularity in the monolith, or people did not care, right? Because you start and then someone else comes and maybe doesn't care. I know I'm also working as a consultant. I do not know, I care always, but it's not my baby, because you should treat your software as your baby, then it will be always well treated, it is nice, it's structured stuff, and then this doesn't happen. Okay. Now the point is, what I already said is, does the size matter? The biggest problem about microservices is the name of it. So it's neither a service nor is it micro. And it's really not micro. Micro is more, there's another architecture style, it's called serverless functions, where your modularity are functions, and that's small. That is something micro. Here, micro simply means it's smaller than big. So that's the the term micro. And that was misunderstood by a lot of companies. You can't imagine how many customers that I have with these 20 microservices and a very small team, and they suffer from updating to the newest version of something. They suffer from complicated, they have to navigate between the modules and stuff because they are not very well split. Now the scope matters, and there is a term, bounded context. Who knows about domain-driven design? Domain-driven design is a book written by Eric Evans 20 years ago, and he was talking about or writing about how we could write better software with the idea that the business should be, or the domain should be, in the center of the application. So we don't split by technical stuff, we split by domain or subdomains, or in domain-driven design, we talk about bounded context. And the bounded context is like a part of your whole domain model, right? And this bounded context fits very well the idea of splitting things. Now, what people when building software often forget is maintenance, because if you start with a big system, sometimes it's in maintenance mode. It could be, it must not be, but it could be in maintenance mode. And there you typically have less developers than during the project. So you should not, probably when you think about the software architecture, you also should think about how the application will evolve, and not just now, how it works now. By the way, currently there is a trend, it's called monolith first. Martin Fowler is also talking about monolith first, that we first start with monolith, with a modular monolith. Spring has even a framework for that. It's created by Oliver Tropom. It's called Modulith. That's a fantasy name, that's not a real name. And this means we have a modular monolith, because the most important thing about modularity, or about everything in software development, is modularity. And if we look at this picture, we have on one side the modularity, on the other side the distribution. And the difference between a monolith and a microservice is just the distribution. So a monolith runs in one process, microservices runs in many processes. But if you don't do that in a modular way, then you end up with a big ball of mud. And what's even worse is a big ball of mud made of microservices, because a big ball of mud with a single code base is simple, right? You can use tools like Structure 101. There are a lot of software architecture management tools out there that you can use to analyze your code, because it's all, I mean, we use Java. Everything is statically typed. We just can analyze it. We can move it around, refactor it. It works. But if you have that over REST APIs, then you have a problem, right? You need to have your runtime. You need, for example, distributed tracing, that you can find out which microservice is really calling another microservice. And so a distributed big ball of mud is the worst thing that you can get. And funny, Simon Brown, also speaker, is from Jersey. He once said in a talk, I can't remember in which one, that if you think microservices are the answer, when you cannot build a modular monolith. So you should always think about modularity, and in the end, it really doesn't matter if it's a monolith or if it's distributed into microservices. That's the point here. And getting a big ball of mud is relatively simple. Here, in the most simple example, we have a customer that could have orders. The orders need products from the catalog, and now we also want to know which order belongs to which customer. We have a cycle, and we have a big ball of mud in the small kind. That's the problem. And the second problem that we have with microservices is distribution. So Martin Fowler also wrote once in a book or in a blog post, I can't remember, the first law of distributed object design: don't distribute your objects. Because the network is not reliable, the network is not secure, the network could fail, the network is slow, so you shouldn't do that. And I created like 3 how should I say, steps of communication. The first is synchronous. So that's typically if you're doing microservices, you use REST APIs and you have a synchronous communication. And I don't know if you know that, but there is a website, microservices.io, and it has a pattern catalog. There are like 35 patterns, more or less. And you know what a pattern is, right? A pattern is a solution for a common problem. So that means if you're using microservices, you get 35 problems. No, that's not true. I'm joking. But a lot of these patterns, or not a lot of these patterns, but other patterns are about reliability. I already mentioned circuit breaker or timeout or retry. All these patterns are there because we have problem if we do synchronous communication. Then we could go and say, no, we don't do that. We use some messaging system, whatever. If it's Kafka or ActiveMQ, JMS, something old, doesn't matter. We just do requests, and we do that asynchronous. And what I want to show here in the middle, that's called a request reply pattern. So we do the same as we do with synchronous communication, but we do that over middleware, and we hope it's simpler. But the problem is it's not, because we have requests, as we can see here, 1 and 2, and someone is waiting for the response. So he's not actively waiting like with the REST APIs, but he's waiting somehow. And I have a funny story. The biggest telecommunication company in Switzerland, they were also doing like TV on demand when this was popular, like many years ago before we had Netflix. And for that, you need the box. And you could order the box on a web form, and but the order was then fulfilled by the SAP system. And because they wanted to decouple the web application with the SAP system, they decided to do that in a request reply mechanism. So they sent a request to the SAP system, and then they waited for a certain amount of time. And what do you do if you never get an answer? You can retry. You send it again. Now, that's what they did. So they waited like 2 minutes or something like that. And in test, everything worked fine. But in production, the SAP system was very slow. And the limit was not enough. So a lot of people suddenly get 2 of these boxes, and other people never get a box because they were run out of boxes. And that's a problem with this request reply mechanism. This only works if the receiver is idempotent. That means it knows that you already get the request and doesn't do it a second time. So the most decoupling mechanism that you could have is event-based. So event-based means you just send events, but you don't wait for a response. The response will come in terms of another event, but these are all kind of business events, and you don't wait for something. So that's just the way it works. So this is event-driven architecture. This creates a very loose coupling, but it's very hard to observe, for example. So you have to have something in place that you see where for example, your order is currently. Another problem with microservices is this one. We know the n+1 select problem from databases. Hibernate creates that if you are not careful in prefetching data. And the problem is, if you move that to the client, so with REST APIs, it gets even worse because there's more latency than with the database. So for example, we have a client, another microservice that calls the customer microservice and says, give me like all customers from Dublin. And then I want to have all orders of these customers. So I will probably create a request per customer to this order service, and this will be very slow. So these are problems of microservices, and they are mostly because of synchronous communication and because they are too micro. But we have different, I call them distributed architecture patterns. What we often see are kind of anti-patterns on the right-hand side. So we see the integration database very often. Integration database is also a pattern named by Martin Fowler. This could be a way to do that when you're transitioning from monolith to microservices. Then you don't want to split the database upfront because you have referential integrity, for example. You have a normalized database schema that's very hard to split. So you can start and move the business code. But what we often see, or I often see, especially with single-page application frameworks, I see monolithic front ends. And currently, there's no real solution. So they're working on micro front ends. There are technologies. Angular has some libraries, more or less, that you could use to avoid that. But the problem here is you just move the problem to the front end. So if we are Java backend developers, our problem is solved. We have 2 microservices, we are good. But now the JavaScript developers or the front-end developers have the problem. And there is a architecture style that I like to talk to you about in this talk. It's called self-contained system. And self-contained systems has everything included. And self-contained systems has also a website. The content of my talk is on the Creative Commons license because you can download the slides there. Also, not my slides, they're not there, but the content in the next section of my slides. And I like to introduce self-contained systems first and then show you how we do that in a modernization project that we are currently working on. Self-contained systems is a architectural approach that tries to do the same as microservices. So we want to split a huge system or a bigger system into smaller parts, but a bit different. It relies on the concepts of bounded context that I already introduced before, and it was created by InnoQ. InnoQ is a consulting company from Germany. They have a very good blog, by the way. So if you go to innoq.com or .de, then you find that a lot of good information about that. And self-contained systems try to cut a monolithic system in separate pieces. And such a piece is called a self-contained system. Now you can go home, that's it, more. You don't need to know more. Now, the interesting thing about that is that it contains everything. So we don't split out the UI. So we have a system that is from front end to back end self-contained. That's why the name. It may also contain optional API. So if you want to provide an API to like a mobile device, for example, or to another service, then you can do that. Or additionally, you can also split the self-contained system in smaller parts if you like to. So you could use self-contained system architecture and say, okay, here we have a service that everybody needs. We split out the microservice and use that microservice. So it's not forbidden to use microservices if you're doing self-contained system. The most important thing, or a very important thing, in my opinion, is that each self-contained system has its own data storage. That gives a lot of freedom. So you can choose, for example, if you have kind of graph data that you want to store in a graph-oriented database, you can do that. If you're a product management service and you want to provide a search service, you could use Elasticsearch as a search engine, for example, or you can use just any other NoSQL or SQL database store that you want to use. Important is the second part of the slide. Redundancy is very important with self-contained systems because you want to have self-contained systems that are independent. That means we don't want to have synchronous calls. So we want to stay on our own. That means we need all the data that we need to fulfill certain use case. Right? I will talk about that later on. Now, the problem that we have, how do we integrate that? So if you have 2 applications, for example, an order management application and a product management application, how do we display the product data? So first of all, we want to copy the product data. But maybe that's not enough. We want to edit the data, but we don't edit data that is not our own data. So we want to go to the other self-contained system. And this is simply done by links. So because we have usually web applications with self-contained systems, we could do links. And by the way, one of the biggest self-contained systems that I know, it's not a self-contained system because they started way or years before we were talking about self-contained systems, is Amazon. It's not that easy to spot now because they did some rework by the UI. But if you're in the fulfillment process, so you add a book to the basket, and then you go to your shopping cart, then you see that the UI doesn't look exactly the same. And if you go to the payment page, the page looks totally different. That's because these applications are not made by the same team and probably also not by the same UI technology. Maybe. That's something that I don't know. Now, how do we integrate self-contained systems in terms of logic, for example? I think an asynchronous or event-driven way should be the way. So you should avoid, if you can, any synchronous calls from one self-contained systems. I will talk about that in the modernization project, how we do that. But if you need to, you should use an asynchronous way, for example, Kafka or JMS, or even a database table will do the job. Because we do kind of asynchronous calls, we may not have this consistency that we had before in the monolith. So we have to deal with eventual consistency maybe, but because the self-contained systems are not that small, this is very much reduced, right? So if we do on a microservice level and have fine-grained microservice eventual consistency, we have really eventual consistency. So, and in terms of self-contained systems, the system is usually big enough, so it forms a bounded context that more or less all the use cases that are transactional could be fulfilled by a single self-contained system. Now, the differences of these two, first of all, self-contained systems are usually larger than microservices, and they have a UI. That's the main difference, in my opinion. They are autonomous. Microservices are never really autonomous because they usually need another microservice to do something, and they are not on their own. And the integration style is usually no integration style in terms of API calls. And on the other hand, we often have synchronous APIs. And the cool thing about self-contained systems, in my opinion, is that a team can fulfill a vertical slice through the application from the UI to the database. Everything that they have to do is team-oriented. And I also think that microservices initially had this approach because in my opinion, the reason to split the monolithic application is because it is too big. And you have to have too much people in the team. You have a lot of communication going on. You want to split that to be faster and more efficient. That's the reason for microservices or self-contained systems. User interface I already said, and the deployment is also a bit different maybe because the self-contained system you can deploy independently because you don't have anything from other systems usually. But if you have microservices, and depending on how you do that and how good you are at API versioning, you may have dependent microservices that you have to deploy together anyway, because depending on what you're changing, you cannot just do that independently. But this is more a problem of the organization, problem of the cut of the microservice and not of the microservice architecture at all. So if you look at the advantages, we have resilience. So resilience is there by design because we don't call any other services synchronously. We don't have to have a problem with resilience. Scalability is the same as microservices, by the way. Scalability is very often not so important, right? So scalability is important if you're a company with a lot of users, right? Then you need to scale. But if you have, like we have in Switzerland, we don't have this Adam Bean is always talking about web scale applications. Maybe the online jobs on timetable services or stuff like that could be scalable, or some payment systems maybe. But most of the other systems, even if it's a web shop or so, it's not that scalable. Then, and that's very important in my case, self-contained systems are open to integration. That means that it really doesn't matter if a self-contained system is our own system that we've built or if we buy it. And in retail, wholesale, you buy a lot of systems because, for example, logistics you don't implement yourself. There are a lot of products out there that you can use. As I said, they are independent because you have everything from UI to database. You can choose. That the question there is more, do you really want to choose? So do you want to give your application team all duties to change the architecture internally and the technology and whatever? Maybe you end up with a problem because then you cannot exchange team members from one team to the other. So maybe you need some kind of standardization. By the way, Zalando is not working here, right? It is. Zalando is organized that they can really independently choose their technology in every team. So they are separate from the others. And the best thing, but that's also with microservices, you can modernize the system. And that's something that's very important. That's something that we forgot like 25 years ago, that someday we have to replace the system. Now let's go to a project. We are in a very, very early stage. So I'm working for the biggest wholesale company in Switzerland as a consultant. I'm architect and the lead developer there. And the system is from the greenfield time, so it's like 25 years old, probably. The UI is Eclipse RCP. That was very popular from 2003 until 2010, where we built system with that. We have JBoss application server in the backend. We have traditional relational databases, and we have a monolith, or we have two monoliths, in fact. And the problem is that the team is not so big, but the system is a bit complex, but it has a lot of accidental complexity. So there is the regular complexity. Yeah? So you have some business requirements and they are complex, maybe. And you have this complexity also in your code. Accidental complexity is complexity that is not required, that comes by using the wrong frameworks, using the wrong patterns, not understanding how to use tools. That's accidental complexity. And because the team changed in the last few years, we have such accidental complexity inside as well. And I was starting last summer with this project, but with another scope. My scope initially was to introduce Vaadin in that company and to replace Eclipse RCP with Vaadin. And I was looking at the system and say, hey, I know that system because I was already working on that like 6 years ago. That's not your problem, the UI. The problem is the whole application. So we have to have a look. We also have to find out how. And this picture is from the lead of engineering of that company, and he tried to condense the wholesale domain model in a simple picture. So we have on one side the flow of the goods that we sell from left to right, and on the right to left you have the money that comes in from the customer. And we need like several domains to do that. So for example, we have the procurement with product management, the whole inventory that is there. Then we have supply. That means we have suppliers to get the goods. And then we have sales. We have a web shop. We have call center. We have markets in Switzerland where the customer can go in and somehow, if it's on the web, then we have to distribute it. So the company also has trucks to deliver the stuff. And we started with that, and we finally found out, and that's why there are these colors. We could, you don't see that very well, that this would be blue, the receivables and the payables, so we have finance somehow. But this is SAP, it's not our problem, but we have a lot of interfaces to the SAP finance system. Then we have supply and distribution, that's logistics somehow. And we have warehouses and stuff, and this could form kind of a subdomain of the whole domain, and then we split sales and procurement. And sales has this square around it because this is the core domain. In the domain-driven design, you also talk about the core domain. That's the most important part of your business, and that's where you usually should take care of it. And all the other parts are usually called supporting domains, and these are domains that you can buy software for. As I said, we have SAP, for example. We also have logistics software for warehouse management. You don't have to do that by your own because you don't get the benefit if you do it by your own. You just can buy the best product on the market. And this led us to this kind of system overview. And this is a high-level kind of self-contained system view. We'll tell you why it's a high-level thing. First of all, we have the inventory management system that should be green on the left upper corner. And this has just write data. So we split read and write data. Means we have really data that we produce, that's marked with the W, that's write data. And then we have a customer management system, and there we already have read-only data. There's missing a line, I see in the diagram, because we have customers that have special prices, because wholesale is B2B market, not B2C. So each customer probably has its special price for some of the products. And that's why we need the inventory in the customer management system when we want to create custom specific prices. Then I go down, we have a delivery system, we have logistics, two systems, because in the brackets you see names, these are products that we already have. So we will never do a system for our truck management. We will never do a system for our warehouse management. They're already in place, but as you can see, they are already self-contained system. I mean, these companies delivering this system don't even know that they are self-contained system, but in fact they are, because they get inventory data, they get customer data, and they have their own write data. And finally, we have sales. Sales is just one box, but that's not true, because we will have many self-contained sales systems. So we will have a web shop that will be kind of a self-contained system. We will have software for the market, like the cash desk software, POS, point of sale software that we have there. And that's also kind of a self-contained system. And here, the same principle, we always replicate the data. The integration between the system is not on the picture, but this happens all over messaging. So that's all synchronously. That means if we create an order in the sales system, this will be sent to a queue and then consumed by the delivery logistics systems, and they will do something with the order. So we don't have any, or we don't plan to have any synchronous calls between the system in our system. That's the idea. Now, if we do that in a company, we have to think about the overall architecture. And if you're doing architecture work, you can split that into micro and macro architecture. And the idea of that is the micro architecture is on the self-contained system level. So there you can, for example, do local optimization. You can define how the developers work, how the team is built. You can have kind of your own design principles depending on which domain you are, because they are not all the same, right? Because as you can imagine, a product management system is very boring. That's a Vaadin application with tables and data, and a lot of data, because a product can have a lot of attributes depending on what you want to do with it. Or you can choose your data access framework, or, for example, we also have search engines in place for the product management. But on the other hand, what we also want to have is a so-called macro architecture. So we want to standardize on a level where it makes sense, especially because we assume that we want to exchange people in the teams. So because we will do a modernization, so everything will be created more or less from scratch. We will take things over, and then the people will move around in the project and also in the team. So we have to have something that is standardized. So we want to have like kind of a system landscape wide standards. For example, how do we do APIs messaging, for example, and especially everything that has to do with operations we want to standardize so that every system works the same way. Observability, tracing, everything should be done the same way. And for us, this means, or our macro architecture, we use Vaadin for the applications, except for the web shop, because this is already new and built in React. And for the other things, we want to use Vaadin. So what we need is a design system. A design system is, or goes beyond UX system. So design system also means component, behavior, how people are working with the application, so that also people that are maybe working in multiple of these self-contained systems can work there. And we need a link database, because we want to provide links in the menu, for example, but we are in our own self-contained system. So we need to have the links to the other system that we need somewhere centralized. Then we do replication. All the read-only data will be replicated from one system to the other. Currently, the wholesale company has a data model that has little more than 800 database tables. So there will be a lot of work to split that, because most of them are are normalized, and it's very hard to split there. And we also have ActiveMQ in place. Currently, we are thinking about Kafka as well, but the orders are already transmitted to the other systems like the logistics system or ActiveMQ. And we have some ideas that we want to keep the technology more or less standardized for all systems. We also have Apache Camel, for example, for the integration work. And now the question is, how do we split our monolith, or how we do that? And this is relatively difficult. And the problem about modernization projects, what I had to learn, is they take way longer than expected. Not because it's a lot of work, it's more because you find a lot of things. Because it's not just an IT project. If you create something new or want to replace some part of the system, you should talk to your business. Because not only the software is too complicated over a few years, but also the business tends to become too complex. They also have accidental complexity. And so this gives a lot of work on both sides to align this and to get a new idea about the business. But for splitting monolithic systems into microservices or self-contained system, there is a strangler fig pattern that's also described by Martin Fowler. I don't know if you know the strangler fig. That's a plant that wraps around the tree, and finally the tree dies inside because it has no more nutrition. And then the tree is away, but the structure is still there. It's the fig that makes the tree. And that's an approach that we can do. So we have a database, business logic, and the RCP client, and we can start to move. And it's not very good visible, but there's some dotted red lines. That means we allow some violations during the phase where we move from one to the other. as, for example, the integration database that I mentioned before. There could be that the new system still accesses the old database. We already started with a new system that is built on that, and this just uses views currently. And once we have the replication mechanism in place, because that's currently prototype, we move that to a replicated table and no longer to a view. So to conclude, in my opinion, for this scenario, this ERP system, or any other type of ERP or business application, self-contained systems are a very good fit because it's the optimal modularity that you need. And you have everything from UI to backend into a silo, and you can have a team that is responsible for that, that knows everybody about the vertical slice in your business domain. And because you try to avoid synchronous calls and you only integrate over links, for example, or you do data replication, you have no dependency during runtime or close to zero dependencies. That means your system is way more reliable. And if you go back to that slide, what I didn't talk about is these systems have totally different requirements in terms of scalability, in terms of operation hours, because the inventory system runs from Monday to Friday during business hours, whereas the web shop should run around the clock 24/7. So we can also take this into account. And finally, this supports continuous modernization, so we can go ahead and add a new self-contained system, replace it with another one. That would be very beneficial. So let's have a look. Are there any questions, Shaf?
Yes, there are. Vincent asks, is backend for frontend in the idea of SCS?
Backend for frontend is something completely different because it's more on the API level, where you create like an intermediate layer between the client and the backend. And backend for frontend is a pattern for microservices, where we want to access multiple microservices from the frontend. So the answer is no.
Okay, we also have another question from VS Salendra Kumar. How this architecture looks in a typical e-commerce application?
Yeah, exactly as I described, because an e-commerce application has the same architecture as our wholesale ERP system, because you have usually an e-commerce web shop, so you have something customer facing, but I would say the most software that you have in an e-commerce company is the back office software, like inventory management, customer management. There are a lot of systems for example, managing search engines, optimizing product quality. All the logistic stuff is not visible for the end users, so it's the same architecture finally.
Cool. Then we have one more question, an interesting question. How do these self-contained systems share data when their databases are separate? Obviously, in microservices, we always have this. So yeah, go ahead.
Yeah. In our case, we do replication, and I would always do replication because usually you have really data that is produced in a certain self-contained system. And maybe this data is needed in another system, but usually this is not time critical. So for example, if you create a new product, it takes a very long time until this can be sold. So you need to define the price. You have to, if you're into e-commerce, you have to add all the keywords and stuff for the search engine that the product can be found. You need to add pictures. You need to add stuff around the product. And then there is no need to have immediately the product into the order system. So replication doesn't need to be real time, for example. That's what I want to say. So in my opinion, it's replication. And on the other hand, if you have this data that is moved through the system, like the order, that is then sent over asynchronous ways. And should contain everything, by the way, and should contain everything that is needed in the target system, or the target system has a replication of the data, and then you can also send simply the IDs of the entities, for example.
Nice. I think this is, if I understand the question correctly from Himal, doesn't it make difficult to improve later as these SCS will become more like separate systems?
Yeah, that's exactly the goal. So you really want to have separate systems, but because the problem that we currently have in a monolithic system is that we have a monolithic system, and that they will and the improvement will always be locally. So you don't want to improve the whole system at all at once. You want to do that per system. Yeah. I just take questions from my audience here.
Sure.
Are there any?
The primary way to communicate between the self-contained systems would be by events.
Could you just repeat?
Yes, the question was, is the primary communication between the system events? And I would say yes. So data that must be transmitted to other systems that should run through the system are always events, yes. Do you have other questions, Shaf?
No, we don't have other questions on this side. If you have any other questions there.
Any questions left?
How would you recommend to break if you already have a big amount of client-side code, big, as you say, a big monolith of actually client-side code, right? So for the proposal of separating, you need to actually separate that. And if you're already not using some library like the one you're proposing, you already have lots of React or something, but you want to use the pattern, is there any recommendations you have?
Because I'm not a JavaScript developer, no. But what I would try is to do a separation that also could mean that you have to copy code. So you have to maybe duplicate some of the code, or you can split it out into a library if you like to. But that, as I said, micro front ends are not ready, in my opinion, yet. That would be the closest, right? But if you would start with, I mean, self-contained systems, people are more or less recommending server-side rendering for that, because then you have everything on the server. So Vaadin is not server-side rendering, so I already break with that idea. If you are into React or if you're using Hilla, you also have this slice, right? And then you will also share things. But sharing usually means another library or add another library and not share code. Yeah. You will also, by the way, if you're already on that topic, you will also not have a monorepo. You usually have separate repos per self-contained system because we want to have fully independence. Yeah.
So we have one more question here, Simon. Being pragmatic, some end-to-end operation involves synchronous communications among different SCS. It is unavoidable. What do you think?
In our case, it's available. It's avoidable because we really don't have any. We didn't identify any need for a synchronous communication between self-contained systems. It's already about the split. So if you have communication, especially if you suddenly have bidirectional communication, your split is wrong. So you didn't split at the right place.
You want to take it from there? There's a comment though from Jesper would be here. Shared libraries in distributed systems tends to become bottleneck.
Yeah, that's true, but I'm not talking about shared business libraries. I'm talking about shared technical libraries. So for example, the design system, the menu items, such code, or helpers or utilities. You will never share any business code between self-contained systems.
Do you want to take a question from there? And if you can repeat the question, would be nice.
Here are no questions.
Okay, perfect. Then I guess we can close the session. Thank you everyone for joining. Thank you, Simon. Thank you, Ireland, for making it extremely nice and lively. So have a great one, everyone. Thank you.
Thank you.